Good morning. I'm Terry DiVittorio, General Manager of Defense Solutions North America. I'm excited to be here this morning at the IDGA Counter UAS Summit to share with you over the next 30 minutes our perspective on the current and evolving drone threat, as well as the capabilities of our system to mitigate these threats. I've got a pretty full agenda to cover with you over the next 30 minutes, from telling you how D-Fend and how at our company we see the current threat landscape with regard to drones. And then I'll dive deeper into specific threats associated with these drones and threat mitigation techniques. Next, I'll share with you how our system and capabilities provide a truly unique takeover and control solution that is non-kinetic, non-jamming, and ideal for urban environments where we eliminate the potential for collateral damage from those traditional mitigation methods while being able to safely land the drone in a pre-designated safe area. Next, I'll share with you how our flexible and adaptable configurations and deployments provide our customers dynamic counter-drone capability on the fly to meet whatever scenario they encounter. And then I'll present some real-world use cases designed for all the vertical markets we support. Lastly, I'll share with you what we feel truly sets us apart as a world-leading drone company and our passion to stay one drone threat ahead with a focus on safety, security, and continuity. A little bit about myself. I'm a former United States Air Force non-commissioned officer with a cyber and tactical communications background, and have been supporting U.S. government national security and law enforcement agencies for the past 30 years. At D-Fend, I lead our North American team, who are delivering and supporting our systems for defense, law enforcement, homeland security, aviation security, critical infrastructure customers here in the U.S. and Canada. A little bit about D-Fend. D-Fend is a global company. We are headquartered in Israel and have offices in Europe, the UK, United States, and Southeast Asia. Our autonomous end-to-end counter-UAS solution is in operation today, supporting a myriad of global customers. Our team members are steeped in the domains of cyber, tactical communications, signals intelligence and interception, and military field operations. And they bring their experience and expertise to the design, development, and continual refinement of our system platform. Just to give you a quick sense of the markets that we support, these verticals are where we are today and over the past 3 years deploying our EnforceAir system, and is making huge impacts on protecting against small UAS threats. We are downrange with forward deployed military units. We're at our borders with Homeland Security and law enforcement agencies. We're situated in and around international airports, as well as domestic airports. We're traveling globally with protective details, and we're providing current counter-UAS protection at major sporting events, laboratories, and power generation facilities. Where we really cut our teeth over the past 3 years is supporting these top-tier agencies, real forward leaners and early adopters in the counter-UAS space. The partnerships we've established with these high op-tempo operational customers has allowed us to establish a feedback loop from the front lines, where we're quickly able to integrate new enabling capabilities into our systems based on the real-time observation of the tactics, techniques, and procedures of those adversarial entities, criminals, and nefarious groups our customers are battling in the counter-UAS fight. The next few slides I'll share with you are just some videos highlighting the credible small UAS threat. In the upper right-hand corner, we're all aware of the Gatwick Airport event, where there was days of operational delays and millions of dollars lost in revenues and costs. In the upper right-hand corner, maybe some relatives delivering some care packages to their loved ones, spending some time in one of our luxurious federal correctional facilities, where contraband and delivery of contraband by drones is a major threat and major issue. In the lower left-hand corner, we are aware of the drone-delivered assassination attempt on the Venezuelan president. And in the lower right-hand corner, a mega sporting event disrupted by drones, for which here in the United States over the last several weeks we've seen happen at Major League Baseball events. We know firsthand that ISIS is using small UASs to conduct ISR on our troops in Iraq, while also using high-endurance drones to deliver lethal payloads in attacking our troops forward deployed. Other attacks to high-endurance drones and do-it-yourself drones include a radioactive payload discovered on the roof of the Japanese Prime Minister's office and a drone attack on a power plant in France. In the lower right-hand corner, we see what the drone traveling at speed can do in impacting the wing of a large aircraft. All the drones used in these incidents were commercially available drones or do-it-yourself drones. Buy them at Amazon, have them delivered next day, no background check, no certifications or license, just unpack them and you're good to go. In addressing all the major threats, we focus on high-endurance drones. Our sweet spot or focus area is on what the Department of Defense has categorized or established as Group 1 and 2 drones, with a focus on high-endurance drones, do-it-yourself drones, and Wi-Fi drones. High-endurance drones are mid-sized to large-sized drones which can fly several kilometers in distance with the ability to carry payloads of several kilograms. These high-endurance drones, which can be purchased commercially or built via off-the-shelf parts, utilize long-distance radio communication in order to fly large distances, while transmitting telemetry and high-resolution video back to the remote control operator. Wi-Fi drones are also small drones which are controlled via smartphone apps. These drones are connected to the smartphone via Wi-Fi communication. Due to the Wi-Fi communication limitation, these drones can only fly for a few hundred meters. But some manufacturers have extended this range by adding additional remote controllers, which in turn boost the signal strength in the drone's range. The short-range Wi-Fi drones, such as DJI Phantom 2, Phantom 3 Standard, DJI Spark, Parrot Bebop, etc., are usually considered as lower threats due to their limited range, small size, and inability to carry large payloads. So within this Group 1 and Group 2 drone environment established by the Department of Defense, we have to ask, what are the characteristics from these types of drones and the threat potential? For D-Fend, asking that question allows us to prioritize the threat and focus our research and development efforts on those types of drones that have the potential to deliver the biggest impact. Whether the drone is being used to attack or for trafficking, to disrupt, collide, or crash into something, or to conduct intelligence collection, the characteristics of the drone will vary and must be evaluated and then prioritized. From this evaluation and prioritization, we characterize drones as either major or minor. Major drone threats are those that utilize Group 1 and 2 drones that carry payloads between 3 and 12 kilograms, travel distances between 4 and 20 kilometers, and operate sophisticated protocols like OcuSync or Lightbridge. This, however, is not our only focus. We know that smaller, less lethal Wi-Fi drones can still present a significant threat, so these types of drones remain on our radar and can be mitigated by our system. There's solid evidence and data to support our approach to focus on high-endurance drones. The high-endurance drone market is predominantly controlled by a single vendor, DJI, with over 85% of the market share, while additional small vendors are competing for the remaining 15%, including small Wi-Fi and do-it-yourself drones. Our system, the EnforceAir, is the only solution available on the market which can take control over these long-distance proprietary radio protocol types of drones. Our drone library is focused on these types of drones and validated by customer feedback from real-world operations from the field, where drone-driven terror and criminal activities have been mitigated and controlled by our system. Next, I'd like to talk about traditional counter-drone technologies and then how we look at the counter-drone technology environment. There are challenges with traditional drone detection and mitigation methodologies. Current detection solutions include optical and radar systems, which struggle in problematic line-of-sight environments or situations due to refractions or obstructions. Current mitigation solutions include radio signal jamming, which potentially enhances environmental signal disruption to Wi-Fi, GPS, or network communications, and kinetic solutions, which introduce hazardous scenarios involving rogue falling objects or collateral damage. These traditional methods won't work, or should I say, they won't work well in highly populated urban environments where line of sight and cross communication signal interference is likely using those techniques or technologies. And kinetic solutions, well, a crashing drone is not really a positive or acceptable outcome. For sensitive urban environments, direct access to the remote control communications is essential, where control can be taken from the remote control operator, and then once the control is obtained, the rogue drone can be safely landed in a pre-designated area or zone. So knowing all these factors, analyzing the drone landscape, and gaining a valuable insight into the techniques, tactics, and procedures of our adversaries, criminals, terrorists, and not to mention the careless, clueless hobbyists, we at D-Fend have designed an autonomous end-to-end counter-UAS system, the EnforceAir. EnforceAir offers full lifecycle drone protection from detection through mitigation by taking control of the drone and landing it safely through utilizing the communication links between the drone and the radio controller. EnforceAir is non-jamming, non-kinetic, and requires no line of sight, avoiding collateral damage as an environmental interference when operating in urban and sensitive environments is less likely. The EnforceAir delivers a logical life cycle of capabilities required to truly take over the rogue drone with a focus on the communication link running between the drone and the radio control operator. I'll quickly go through each of the phases here of the EnforceAir life cycle. First, the system detects and alerts an operator to a drone activity in a specified detection zone. The system passively detects drones and remote control operators within a 5 to 7 kilometer radius, depending on the antenna type. I'll talk later about configurations and deployment types, including the multiple antennas that can be deployed with the EnforceAir system. But this action does not require clear line of sight and specifically designed for highly populated urban areas for mitigation. Next, the system locates and tracks the drone. Real-time tracking location is obtained by extracting GPS location from the drone via its telemetry signal. High-endurance drones must use GPS for long-distance flights, providing the EnforceAir system the ability to capture this information. The EnforceAir then identifies the drone and provides the drone with a unique communication identifier through extracting various parameters and creates a tail number contributed to drone classification. Here's where our system can determine authorized drones from rogue drones, essentially identifying friend from foe. During the data extraction phase, the EnforceAir extracts the drone's takeoff position and home point. The system extracts GPS accuracy mid-air and also provides the estimation of the drone's pilot position. These parameters can be extracted in cases when the remote control operator is not detected by the system, for example, like during the downlink only. Next, and lastly, the EnforceAir presents 2 mitigation options to the operator that can be either manually set up or configured to enable automatically when the drone enters a predefined protection zone. These 2 options are the fend off or take control and safely land options. When the fend off option is selected, the system mitigates the rogue drone by disconnecting the control signal from the drone's radio control operator, causing the drone to fly back to its original takeoff position or home position. When the take control and land option is enabled, the system transmits a unique control signal to set a new flight plan for the safe landing of the drone at a predefined position. In the cases where full takeover is not allowed, we fend off the drone, commanding it to return home while maintaining disconnection between the pilot and the remote control operator, as well as the drone. Next, I'd like to talk about the operational flexibility of our system. The EnforceAir system was designed to be flexible and adaptable to meet varying customer operational requirements and mission sets. The system is lightweight and portable and can be fully assembled and operational by one operator in less than 5 minutes. Over the next few slides, I'll describe the components of the EnforceAir system and the multiple configurations and deployment options available to our customers. At its core, the EnforceAir is composed of a software-defined radio, or SDR. The SDR processing unit, which processes all of the passive and active elements, includes radio receivers, signal processing elements, radio transmitter, and initial power amplifier transmitting up to 1.25 watts. The SDR is connected to an AC-DC power connector and then connected to a ruggedized tablet via an Ethernet cable running the EnforceAir browser-based management software. The SDR is MIL standard 810F form factor compliant and mounts easily on our tripod for tactical deployments or on a secured cradle for an on-the-move vehicle deployment. The standard tactical deployment of the EnforceAir system is a tripod, the SDR, and a radome omnidirectional antenna, along with a ruggedized tablet providing the system's user interface. The radome antenna can also be mounted on a vehicle, like that pictured here on the right, for on-the-move counter-UAS functionality. An optional deployment ideal for urban environments is the folding antenna configuration. The antenna provides 360-degree coverage, but breaks down quickly and can be deployed as a covert vehicle kit with the SDR and battery pack in the back of the vehicle. This configuration allows for rapid transformation from fixed counter-UAS protection to on-the-move capability. Lastly, our antenna configurations can be mounted on buildings, poles, or other structures. The The folding antenna seen here provides 360-degree coverage in an omnidirectional manner, covering, while the directional antenna on the right side provides 7 kilometers of coverage for up to 30 degrees down, 30 degrees up angles mounted on a fixed facility like a building, pole, or other structure. Next, I'd like to go through several use cases on typical deployments of our system and different types of environments for which we support. First, we'll start with airports. An airport deployment would typically consist of a combination of configurations. For the tarmacs and terminals, we would deploy a standard tactical system with either a radome or folding antenna, providing 360-degree coverage, while in the airfield, we would deploy several long-distance directional antennas to provide 7-kilometer coverage along the inbound and outbound flight corridors. The number of each type of system, an omnidirectional or long-distance directional antenna, would depend on the number of airport terminals, tarmacs, and runways that would require a counter-UAS protection in that environment. In providing counter-drone detection and mitigation at a border, we would again deploy multiple configurations of the EnforceAir system. Along border walls, we would deploy a series of long-distance directional antennas to provide continuous boundary or perimeter coverage. We would also recommend a covert vehicle kit with a cradle-mounted SDR and battery pack in the back of the vehicle with roof-mounted magnetic antennas for omnidirectional coverage and 360-degree coverage on the move. A maritime deployment. The EnforceAir can also be ship-mounted, either a standard tactical system with tripod SDR and radome antenna, or configured with folding antennas mounted or affixed to a stationary platform, bulkhead, or mast. Once deployed, the system would provide 360-degree coverage for cargo ships, warships, or passenger vessels in the open sea, and as they travel through canals, inward waterways, and harbors. In providing counter-drone detection and protection for critical infrastructure environments, we would recommend, again, a combination of deployment options. In and around the main power plant, for example, a standard tactical system configuration would provide 360-degree coverage for protecting critical assets, while a vehicle kit configuration would provide protection at the boundaries and perimeter of the facility, as well as on-the-move coverage in its surrounding areas. For military deployments or military installations, similar to the deployment strategy for critical infrastructure, protecting military installations would include a combination of deployment options. Inside the fence, a standard tactical system would be deployed to create a 360-degree coverage bubble for facilities, supplies, and personnel, while several vehicles outfitted with covert vehicle kits would provide continual fence line and perimeter protection. And lastly, for highly populated, dense urban environments for which our system was ideally designed, we would deploy multiple deployment options as they were available. First, multiple tactical systems, we deployed both our standard tripod-based tactical system as well as folding antennas mounted on buildings, poles, or other fixed objects. While several covert vehicle configurations could be deployed to provide roaming, on-the-move coverage outside those protected zones. Lastly, I'd like to close with what we believe truly sets us apart from our competitors, and that is our laser focus to stay one drone threat ahead. Meaning we know this is not a static or slowly evolving business or operational fight. Drone threats and those who enable those threats are well-financed, technically savvy, and operationally experienced and proficient. Bad actors are using military and intelligence TTPs as platforms for exploitation. At D-Fend, our team members come from military intelligence technology units with advanced skill sets, experience in tradecraft, core to the counter-UAS reaction or response needs. We use this technical prowess to allow us to quickly assimilate new drones coming off the manufacturing line into our library, along with updates in new drone protocols, providing our customers the most up-to-date counter-UAS capabilities to outpace, not keep pace, with their adversaries. For us, this is chess, not checkers. Our strategy is to always be the partner to our customers who's constantly thinking one drone threat ahead. So in summary today, I'd like to leave you with these 4 thoughts. D-Fend really focuses on control, safety, focus, and future. For us, control, that means the drone threat cannot be effectively controlled unless you can actually take control of the drone. Safety, through safe landing of the rogue drone, provides a safe airspace and continuity. Focus. prioritizing our efforts on those drones that present the most dangerous threat and biggest impact. And lastly, future. Defend's ability to stay one drone threat ahead through our expertise and experience we have within the company and through our close work with top-tier operational customers. Thank you for taking time to be part of this session, and please contact me if you need any further information about Defend or its capabilities.